Okay. Well, in that case, I thought it was very interesting how we were told Scalar uses Monte Carlo simulations. And so I'm yet more interested to see how Pat and John tell us about using them and what we can do with them. I've gone ahead and set it up, gentlemen, so you can share the screen now, and I'm turning the time over to you.
Okay, so let's see. I'll pull this up right now.
Are you going to start, Pat, and then
yeah,
you want to start with the presentation, then I'll go into the Excel?
Yeah, so John's our quant here, and so I'm going to start off by giving us a general overview of Monte Carlo, and then John's going to fill us in on all the good details with the Excel. So first off, I'd say the main assumption for Monte Carlo is that a variable that is outside the norm eventually returns to the norm. So the idea is if you compile enough data and you're sifting through it, when you have pieces of data that are outliers, generally they're going to stay as outliers, and eventually you're gonna come to a more like you're going to come to something that's more close to the median or mean. The things that we're going to be using for this are, like I said, mean, median, and then variance of that, and then just regression to the mean. Those are the main assumptions and main metrics used for any Monte Carlo simulation. So just to give a real life scenario with the poker scenario, which definitely applies to business or anything, I think it's just kind of a mental state that people get in. So if I've won 3 hands of blackjack in a row, people think, oh, like I've won 3, I'm gonna win 4. This is the way the momentum's going, which there is definitely some truth to that. If you've already won 3, the chance of you winning your 4th hand is going to be about 46%, and so it's basically, the Monte Carlo simulation is all about stepping outside of the assumptions in your head and just going purely putting a statistical thinking cap on, in my opinion. And so, but the chance of you winning 4 when you've won 3 is 46, but the probability of you winning 4 if you just sit down at the blackjack table is going to be only 4.6%. And so that's just kind of speaks to how people think when they are winning, and when they think they have momentum behind them, and things of that nature. So for inferential stats, that is a big part of what Monte Carlo is about. As you can see here, this little picture in the bottom right is talking about if you're rolling a set of 2 dice, if you do it 36 times, where are they going to end up? And as you can see, we get a bell curve here. With Monte Carlo, a big assumption, like I said, is you're going to have a lot of things that, there's going to be outlying stats on the right and the left of a bell curve. And the main idea is that a lot of the data is going to be compiled there in the middle. As you can see, if you roll 2 dice, your chance of rolling a 6, 7, or an 8 is going to be the bulk of the data there. A big part of Monte Carlo is that you're using random sampling, so it takes away that human factor, which I think is the biggest part that makes it valuable to be used. Really, I think the thing that makes it the most valuable in a business application is that, in my mind, people don't want to think statistically. A lot of times people are generally optimistic. And so, if I own a business, I want to think we're going to be we're going to be super profitable next year. G is going to be this big because we run a great business, and you're making assumptions in your head that a lot of times aren't based on stats, and that's where Monte Carlo can come in and just be. I would argue that it could be a very humbling way to go about valuation, because you really have very limited touch into how it comes out. So I think that's really the cool thing about Monte Carlo is it is kind of it's a level playing field. You're using random samples of data, and you're thinking about it in a statistical way, not an optimistic human way. So I think that's really the main reason to be using a Monte Carlo is to look at it through a statistical lens. So as you can see here, how this relates to business, there's tons of different things you can use a Monte Carlo to find. Commonly, people are going to be using it down in the bottom right here. This is like a currency price, the price of euro, and we're basically charting all the different routes that we think the euro might go in the next 30 days. And what a Monte Carlo is going to do is it's going to see all the different projected results, and it's going to find the mean and the variance there. And so we can use it to value assets, stocks. You can use it to make portfolio decisions. If we make all of these different kinds of decisions, what could be the outcomes here? I think it's exciting because you could use it for like profit margin. You could use it for projected profits. What are we going to think that the G is going to be in the future? Like Rick said in many of his classes, G has been something that causes a lot of stress for people who are running businesses. And so I think it's cool to be able to look at this through just data. What are the different things, what different metrics do we think could make up long run G, and then just running the simulation and just seeing what are the chances of it going either way. So finally, one of the really interesting things about Monte Carlo is since it's built on data, one of the things that can make it basically useless is like as we saw yesterday, oil futures went down 300%. So when you go into an unsteady market, that's when data and statistics can basically, I don't want to say they're useless, but there's just, when there's a ton of unknowns in a market, a purely stats-based approach doesn't really offer you all that much value, just because no one really knows what's going to happen, and it doesn't really, the current environment we're in right now, or the environment we were in 2008 or 2001 were not things that we had really seen before, or at least, down to the dot. And so it's really hard to use data to analyze something like that, because there's so many other factors. That's when you need to put on your actual thinking cap, and step away from the data. In my opinion, I don't think a Monte Carlo could do you all that much good in a environment like we find ourselves in right now, which is very interesting.
So Pat, let me ask you a question. So I think you're about to turn it over to John for the quant stuff, right?
Right.
Would your last comments about the ineffectiveness of Monte Carlo in times of uncertainty, and I agree with you, by the way, would you also then extract that to say Monte Carlo probably isn't all that valuable in the nearest of terms? So I might not use a Monte Carlo to help me understand next year, but I would use it to help me understand 5 years from now. What would you think?
I'd say next year. Just with all the uncertainty, we don't know.
Forget the current uncertainties. Let's assume that this is January 1st, 2020, and we haven't been put through the meat grinder yet. Okay? And we don't even know it's coming at us.
Right.
So would you use Monte Carlo to think about 2021, or would you not use Monte Carlo for such a short-term estimation?
I think you'd want to use it as a lens, but I think Monte Carlo isn't an absolute solution. I think it's an interesting lens to look at, but I think you need to look at it and understand that it's based on just data, and there's a lot of other things besides just numbers that go into a business. There's a lot of human factors and market factors. So I think you just always have to be thinking about it with that in mind.
Yeah, and I like the way you put that, Pat. It's a lens, and I honestly think that's great. And the lens becomes sharper as it looks further in time, so it's farsighted.
Okay.
Right?
And Rick, do you think, is that just because you have more data to work with? Like if you're looking out 5 years or whatever, it's easy to look back for 5 years or in the past and apply those things?
I think it's more about because over time our results will converge on these statistical means and such. But I'm reasonably confident that in the next 30 years, I can think about an economy that grows at 2 to 2.5% average. I'm not confident about what the next 6 months looks like in the economy at all. Okay, so I think that this Monte Carlo as a lens, if you will, or helping with our lens helps us focus better longer term than it does really super short term. So I like how you've done this. What elements, and maybe I'm getting into your discussion, John, and so stop me if I am, what elements do you think we would use in all the various valuation inputs or outcomes? What elements do you think we might consider using a Monte Carlo simulation for?
Are you talking about, or go ahead, Pat.
Yeah, there's a lot of different things. I'd say, like I mentioned right back here, or wait, I just went past it. I'd say valuing an asset and like projected profits are probably going to be big ones because they're just, I think this, with it, if John pulls up his Excel, it'll show better why. Okay. But
well, no, I understand what you're saying. I was looking for an opinion. So okay, so John, go ahead and take us through some of the eye bleeding stuff.
Okay, let me see here.
So Pat, you're gonna have to unshare.
Okay.
So that John can share.
Unshare. Oh, stop share. Boom.
There. Let's see. Okay. So let's see. Can you all see that?
Yeah.
Okay. Okay. So sort of going along with what Pat said, you basically use Monte Carlo, I think, and again, I mean, this is really, really complex. And so with everything that we did, I think that we still probably like hardly even scratched the surface of really what this is about and some of the math behind it. But so basically what you're trying to do is you're trying to look at a ton of different options, a ton of different scenarios, and come up with the most likely so that you have the best idea of what you're working with and what you're doing. And so what I did for Excel here, and I tried to use Bits and Bytes, which is the company, the firm that Logan and I are looking at. And so for one of their years, they had an expected revenue right here of about $1,500,000. And then they had, and I sort of compiled this, so I mean, this isn't super accurate, but they had fixed costs that were roughly $686,000, and then variable costs of about $450,000. And then I took the standard deviation, which I just took is 15% there. And by using this function, which is norm.in, and then taking random info based on the standard deviation, this is a possible outcome. So this 1,752,000. So we were expecting revenues of about 1.5 million. And then with the standard deviation, it came up with a random value for us using a bunch of data and different things. And this brought us to the 1.7. And so then if you bring that across, so these are all the same. It's doing the same thing. It's coming up with a random value based on what we put in here for the fixed costs. And then again for the variable costs. And then obviously the profit is just your simulated revenue minus the fixed costs and then minus the variable costs. So in this scenario, you would come out on top and you would have profits of about $500,000. If I go here, and I calculate it again. So you can run this just a bunch of different times because it's pulling just random data every time. So it should be sort of in the same ballpark, but it will change. So you can do it as many times as you want. And you can see that this value is changing. And so sometimes it's higher, sometimes it's lower. And then next what I did here is, so this is, I wrote trail, but it's supposed to be trial. And so this is just our like first trial profits are the same as what we have here in this first simulation. And then essentially what I did is I created a data something or other and basically projected this out 1,000 times. And so if you look at this, so this would be running all of that data 1,000 times. 1,000 is kind of trivial. I think that if you wanted to get closer and closer, if you wanted to get more accurate, you could run that more and more times. Sometimes I read about people just doing it 500 times because they thought that that was about all that you needed just for different cases and things. But for this, I chose to do it 1,000 times. And so I ran that out, and then we have the mean over here. And so the mean will also change because it's based on these different numbers. And so in this case, we've got 363,000. I think that I kind of assume that everybody knows about mean and variance and all that, but maybe just in case you don't, I'll explain that a little bit. So the mean is basically just the average. If you took all the numbers, added them up, and then divided by the number of numbers. The median is like if you lined them all up from 1 to 1,000, it would actually be 500 on the dot. So like the 500th value, if you took them from least to greatest and then added them up, the median would be the number that's right there in the middle. So typically your median and your mean should be pretty similar. And in this case, they look pretty good. They look pretty close. And so if you do this, they really shouldn't be too different because they should both be pretty close to the middle of your data set. We've got our standard deviation, and honestly, so a lot of this comes down to statistics, and for a lot of it, it was really interesting trying to learn about, but it's so complicated, and I don't know a whole lot about statistics. But essentially what standard deviation is telling you is it's a way to look at the data and sort of predict what your most common values are going to be, and then as you spread out, how those change. So if you look down here, this is a standard bell curve, and I thought I'd just throw this in so that everybody could look at it. So your mean.
John, is this bell curve live? Is it changing as your data changes?
No, this is
okay.
This is just like an
right.
image, yeah. But so that line right there in the middle, the 0, that would be considered your mean, and then on either side you have one standard deviation. And so that's telling you that from your mean, you should be able to incorporate about 68% of the time. You should be at like the numbers that you project should fall within one standard deviation. It means that about 68% of the time you're going to be coming up with a number that's somewhere in that range. And then you can project that out farther. Rick, you might have a better way of explaining that. I feel like after reading a lot about it, I sort of started, I think, to understand standard deviation.
I think you've explained it in a way that I would try to explain it to someone that I wanted to simply have a basic working knowledge of it. Mm-hmm. You know, we get too deep here, and it's not going to serve any of us well, right?
Right. Yeah, and if anybody has any questions, feel free to let me know, because when I was setting this up, there were a couple of different ways that I watched videos and things, like a couple different ways that you could do it on Excel. And I thought that this way was like relatively simple. And I thought that, at least to me, it made quite a bit of intuitive sense. So that was sort of my hope when I put it together for you. But if you all have questions, let me know. And so then we've got our minimum value. So this just looks for the minimum value that we have in this data set. So again, this changes, and then our maximum value. So it's saying that out of these 1,000 trials, it's telling me that the very best case scenario for this firm is that they'll make $1,121,000, and then worst case is they lose about $500,000. And then risk of loss here. So I set up just sort of a little count if, and then if the value is less than 0, and calculated a percentage. So right now it's telling us that 8.1% of the time you would come up with a negative value. So that means that roughly just under 10% of the time you'll be negative. And so I think that for a firm that's relatively small, I think that these numbers change, but for bits and bytes, that's probably a pretty safe number. And so different firms would just look at this to try and see how often they're going to be profitable, how often they're going to be really profitable, and how often they're not. And then over here, this is just a plot of these 1,000 data points. And so
this is live.
Yeah, this is
Got
live.
it. Okay.
And Rick, you might know a little bit about this too. So this wasn't a standard distribution, and I looked this up and I read quite a bit into it, and apparently that's totally okay. I still didn't totally understand why it wasn't a bell curve, but
well, it's a completely different instrument.
Yeah.
And so it wouldn't look like a bell curve. It's just a scatter plot. Now you might be able to plot a line through it, fit a line through it, and I would imagine that the line you would fit through it would be reflective of that risk of loss.
But yeah, so you could do it. I mean, you can do it a couple of different ways, but that was just how I chose to do it. And I think that it's kind of interesting. I mean, if you start running this out a bunch, so if you're calculating at different times, you'll see that for the most part, the data stays pretty similar. And I think that the idea is that as you run more and more trials, the variance, which is basically the difference in your numbers, like how much they vary, it should start getting smaller and smaller. So as you run more and more trials, you should be able to come up with a clearer and clearer idea of what you actually expect the mean to be, of what you actually expect the standard deviation to be, and things like that. And so that's why you would run like 10,000 or 1,000,000 trials or something like that. And I think that for firms that really do this a lot, they'd probably run way, way more than 1,000. But
yeah, because you construct it once and then just tell it to do its work, right? You can run a million simulations by pressing that calculate now button one time.
Yeah.
Okay.
And so that's just about what I've got for you. If anybody has any questions, I'm happy to answer them.
So I've got a couple, but I'm curious as to what questions would come from the rest of you. What would you have to ask John on this, or even John or Pat for that matter?
How did you come up with the 15% standard deviation? Because I assume that's maybe the most important variable in terms of what it's outputting.
Yeah, and so honestly, for the 15%, I just read online, and as I was going through different YouTube tutorials, this is just what people recommended doing, and it seemed like, for the most part, that was just a safe, a kind of conservative number to use. To me, it seemed a little bit like the logic didn't totally make sense, because I feel like when you calculate the standard deviation down here, I feel like that would be the standard deviation maybe that's a little bit more accurate. And so I felt like this number was a little bit trivial, and I'd want to learn a little bit more about it before I actually applied something like that in the real world. But for me, I just did it because I read online that 15% for something about this size was probably fairly realistic.
Have you tried to simply link to cell B3 your standard deviation outcome in cell D9?
Cell D9?
B9, excuse me.
No, I haven't. I could go ahead and do it.
So what happens in cell B3? What happens if you simply type equals B9? Does that give us circularity?
I would think so, because I think that you need, well, let's see.
Hit enter and it'll tell us. Yep, it gives us circularity. Okay, all right. Well, that wasn't a good idea. So Control Z your way out of this deal.
Yeah, that's, well.
There's something else going on too.
Yeah.
Okay. Well, just don't save it.
That's all right. Oh, there we go.
Okay, cool. So John, I gather from what you're saying, you actually constructed this from scratch.
Yeah, I did.
Well, good for you. Most of you guys haven't done that. You've used some other work to do that. So good for you. There's a couple of things that might make this even a stronger tool still, John.
Mm-hmm.
If that bell curve image could be live, just like the scatter plot, I think it would help you envision some things. And if you're not familiar with how to construct them, if you go to my website, therichardhaskell.net, and you're going to find under the Excel templates a normal distribution template that will construct a bell curve for you. And you might pull some of that code, if you will, and apply it to your data, and it might give you that.
Okay.
I guess I would have a question though. So here you're simulating profit.
Mm-hmm.
Okay. So tell me how I use this in a valuation.
Ooh, okay. Well, I mean, I think sort of along with what Patrick said, these numbers change so much. And I mean, there really is quite a bit of variance that I don't think that I would want to use this. I don't think that I would like count this as rocket science or something. I would definitely want to look at a couple of other ways to do it. But I think that in evaluation, you might be able to use these as potential cash flows or something. Like if you were looking into the future, you could say, that you would expect this to actually be your revenue, like the mean. Okay. And you could probably forecast that out a little bit as long as you were careful about changing the standard deviations and things.
Well, and in this case, I'm believing that what you're calling profit is actually EBIT, is it not? Revenue minus fixed and variables?
Yeah.
Okay. So EBIT is an important input to the valuation estimators, right? SDE, free cash flow. If we're doing a multiple, say an EBIT multiple, EBIT's an important input. How would you change this if instead of looking at EBIT, if I'm wanting to look at discount rates?
Ooh, discount rates. I mean, I think that you could do it in a pretty similar way, but I think that you would just need to have a range of different discount rates that you were thinking about, right? So I think
Well, let's think about how you got what you got. Okay.
Okay.
Up here in revenue, fixed cost, and variable. So you've essentially created an equation that results in this EBIT, right?
Mm-hmm.
Revenue minus fixed cost minus variable cost equals, and every time you run this puppy, those numbers all change, right?
Mm-hmm.
Okay. Well, can't you do the same thing if we're trying to construct RE using CAPM? It's going to be instead of revenue, fixed cost, and variable cost, it's going to be RF, RM, and beta, right?
Mm-hmm.
Give us RE. Or if you're trying to construct WACC, we've got essentially 7 variables at play that go together in an equation. And so you can use this same structure. You just got to be able to morph some of what's happening in the cells so that it results in some outcomes that are the kind of outcome you're looking for qualitatively, not the number you want, but the kind of variable you want to have represented. And in this case, it could be RE instead of profits.
Mm-hmm.
And you would still then find your mean, standard deviation, mins, max, medians. You find all of that. Or it could just be a beta factor. Or it could be something as grand as the actual valuation itself. Mm-hmm. So do you guys remember what Nate was using his very complex structure for last week? He was using it to find the call option value, right? And then juxtaposing that to the price of the company's shares. So you can make some kind of a investment determination. Well, it's just using different variable types. And I was actually kind of surprised that he used it primarily to find the value of a call option. I might have thought that he would have used it to find the value of the asset, or the equity value of the asset, or some other subset, but not the value of the call option itself. So in a follow-up conversation, I know that they do sometimes use Monte Carlo and binomial lattice together to help narrow in or hone in on other variables, not just the price of the call option. But I thought it was interesting how they combined these three. So Black-Scholes model gave us an outcome, and they showed how they got that outcome on binomial lattice, and they showed how they got that outcome using Monte Carlo, if you carried it out to enough iterations, right? So I thought that was a really interesting way of them doing that. But I think that in practical terms for valuation, most valuation firms, even that do use something as sophisticated as binomial lattice or Monte Carlo, typically don't use those tools to apply to every potential variable. They'll have a favored variable they're trying to find using this. Some of them might. I've kind of wondered if Jeff Pickett's black box is yet more sophisticated than I thought it might have been, because now I've seen something from it. I kind of wonder if they're using Monte Carlo 2 or 3 times. And Kira, you and Jacob have had a little bit of exposure to what I'm talking about there, because you know Jeff. Any other questions or comments you guys would have with respect to this?
I have one.
Go for it.
When you were talking about the line on the scatter plot, wouldn't that just be a straight line where the mean is? Just so in this case, 342,000?
Yeah, in fact, right after I said that, Alex, I thought the same thing. I said at first, should that give us some indication of the risk of loss? But here, if you look at the concentration, and it's easier to look at it by John changing it over and over again, the concentration comes into view a little more clearly. You get to see that it pretty much is just a straight line.
Yeah.
Yeah, well, and I don't know a whole lot about this, but I just know that when I was looking it up, because I was wondering why it wasn't a bell curve, and everything told me that that was okay, and that for some reason this was calculating like the inverse of some data or something, and that this was right. You would just have to set it up like multiple times or do it a little bit differently to actually find like the bell curve in this data. But yeah,
what the scatter plot is doing is different than what a bell curve does. If you had the same values on the same axes, you then might be able to see, because of some color concentration, the formation of a bell curve. And I'm saying this from my what is admittedly somewhat limited understanding of these as well. Okay, you know, and at points like when I was doing my doctoral work, I understood them much better because I had to deal with them all the time. But I've tried to shut that door, lock it, kind of bolt it a few times, and try to forget about where it is, right? But I think that I think you can cause it to look like a bell curve, but then it's no longer telling you what this scatter plot tells you.
I think it would look like a bell curve if you were saving the mean value over and over again, instead of saving like the profit numbers, saving the actual output and then inputting that output through 100 different simulations that are running 1,000 different profit simulations. So if you were just saving that mean and then entering the different means that you got into a chart, that would give you an actual bell curve.
That would make sense.
Yeah. Yeah, that would actually be kind of cool to do. That'd be fun.
Okay, then we'll expect you to do that for us then, John.
That's all right. We'll see.
Yeah, be careful what you find attractive. You may be subject to it. All right. Well, look, gentlemen, this is a good job. You guys might remember that we saved Monte Carlo for last, not just because it can be rather complex, but because I don't expect you to necessarily use it in your final valuation report, analysis, and presentation. What that means then is virtually everything else we've done, I do expect you to use, with the possible exception of the LBO, right? So I want you to think back to and review carefully the PowerPoint and maybe even the video on the valuation report, because when Jacob and I presented that, I gave you some pretty good construct of what I expected to see in the valuation report itself. So that means that it's probably reflected in the valuation presentation and is supported by the valuation analysis. So go back to that so you're not leaving out some critical areas that I expect to find. Okay. Any other questions or comments?
Yeah, Rick, real quick. So when we're putting together our valuation report, should we take like one of the sample reports you've given us and kind of use that, the layout of that model per se to input our information into one of those models, or should we just use that as a brief outline and then have our own valuation report flow very similar?
Well, let me answer it by telling you if I was doing it, what I would do. Okay. I'm a big believer in not reinventing wheels.
Okay.
So I would probably go ahead and take an established report. You guys have been given one. You've even been shown it on the screen, give you some additional information with it. I would take that and I would then edit it as fits my company's situation, the text, the qualitative, the context, as well as the analytical. And then remember, if you're going to do that, that particular report that I shared with you, and actually Jacob put it up there for us, I added some elements that I want to see represented here.
Right, which I remember from
but that's what I would do.
Okay.
I think it's just easier for you.
Yeah, it definitely is. I just didn't know if that's something you wanted us to avoid, or if you were okay with it.
Yeah, if I was asking you put together an academic paper, I would certainly not have you follow its structure in such finite detail, but I would ask you to do an abstract, an introduction, meaty sections, a conclusion. So you're just doing that, right?
Okay. Yep. Perfect.
Okay, so remember, next Tuesday, 10 o'clock, we start off just as it's indicated. So John and Logan, you're going to go up first, and then Alex and Jacob. Alex, you're going to have to spend some time with Jacob because Jacob's got a real challenging internet connection, and I will do this separately, but I'm going to be encouraging him strongly to make his way to a place where he can actively participate in that. Okay. And unless you hear differently from me, then I think that he'll have done that, or he'll choose to do that. Then Mason and Pat, and then Kira and Britton, and then Gerson and Griffin. And that's the order that we'll go in. Okay? Any other questions or comments for today?
One last question, Rick. So the valuation report content list that you had with the presentation, if we were to follow that for our written report and then the PowerPoint kind of template that was that was presented to us for the presentation, would that be a good way to also go about it? But just
That's great.
Okay.
Yeah, you bet. You guys know me well enough by now to know that when it comes to these final projects and things we do in our classes, I try to give you rather a lot of latitude. I'm looking more for the quality and completeness of what you're giving me than I am these particular jot and tittle bullet points, right? Now, there are some things that need to be there for it to be complete and for it to be a quality job. But not all of these are going to look exactly like each other because your companies are, if you think about it, widely divergent.